Hello. Today we will discuss about gamma function. The gamma function is important because it is used in the field of mathematics, including probability, statistics and calculus. It is also used for physical calculations such as probability calculation in quantum mechanics and statistical mechanics. So what is gamma function? Gamma function is generalization of factorial function used for natural numbers. So how to represent it? The gamma function will be represented as gamma n. It's a generalization of factorial function. So gamma n, this can be represented in form of integral, integration over 0 to infinite, x to the power n minus 1, e to the power minus of x dx. If you have any integral in this form, this will be represented as gamma n. And the solution will be given as n minus 1 factorial or gamma n, where n must be greater than 0. Some of the properties related to gamma function. The first one is the factorial relation. Is the gamma n, we have already discussed the gamma n is n minus 1 factorial. So if you have any value of n, the solution will be this value minus of 1 factorial. So I am taking gamma of 3. So gamma 3 will be 3 minus 1. This is 2 factorial. Gamma 4, gamma 2, you can put this value minus of 1 factorial. This will be the gamma function value. Then the next one, you have another relation. If you have gamma n plus 1, so you can also represent it by n plus 1 format. So n plus 1 format can be given as n into n minus 1. Sorry, n into gamma n into gamma of n. And we know gamma n is equal to n minus 1 factorial. So this can be represented n into n minus 1 factorial. So depending on the requirement, either we are representing in terms of n minus 1 factorial, or we can represent it n into n minus 1 factorial. So now the relation is given here. So this is gamma 3. Gamma 3 can be written as 2 plus 1. So the solution can be given as 2 into gamma 2. We know how to solve this gamma 2 thing. If you have half, gamma of half, this is given as the root of pi. And you have another relation which is very useful relation, gamma n and gamma 1 minus n. This is equal to pi divided by sine of n pi. Now some of the solution we'll check. And the first one and the simplest one is gamma 1. So what is that gamma 1? So here n is equal to 1. So we'll refer the standard relation. So the standard relation shows this is n minus 1. Now here we have considering n is equal to 1. So when n is equal to 1, this is 1 minus 1. So x to the power 0. So we know x to the power 0 or any function, any value to the power 0, this is equal to 1. So this is 1 into e to the power minus of x. So here, so gamma n, this is equal to integration over 0 to infinite e to the power minus of x. Actually this is 1 into e to the power minus of x dx. So what will be the solution? So what is the general solution? This is n minus 1 factorial. Now we have this one. This is 1. So we know the 1 minus 1 factorial means 0 factorial. This is equal to 1. So the gamma 1 is equal to 1. Now what is gamma half? We have considered this case, the gamma half. Gamma half can be written as integration 0 to infinite e to the power minus x e to the power n minus 1. So this is half minus 1. So it comes e to the power minus x, x to the power minus of half dx. Now to solve this integral, what we are going to do, we are considering x is equal to u squared. So obviously dx can be given as 2u du. So now put this thing in this equation. So it comes, so e to the power minus u square, and it becomes, this becomes e to the power minus 1 and e to the power minus 1, and dx, this is given as 2u du. So after simplification, it simply comes, so you can take 2 out. So u and u, this will be cancelled out. So this will be left with e to the power minus u square du, And we know the standard form of e to the power minus x squared dx. This is equal to root pi divided by 2. And we have already 2 multiplied with this. So 2 and 2 cancel out. This is simply gives you root of pi. So you know that gamma of half, this is equal to root of pi. You can use this depending on the requirement. Now we have another problem. Now here you have e to the power minus of root x, x to the power 1 by 4 dx. Now how to solve it? To make it simple, we will considering x is equal to t square and dx equal to 2t dt. So 2t dt. And the limits will be same, but as x tends to 0, t will also tends to 0, and x tends to infinite, t is also tends to infinite. So just replace this one. So e to the power minus of t, this is t square under root, so this gives you t. And here x to the power 1 by 4, so t square to the power 1 by 4, and into dx, this is equal to 2t dt, 2t dt. So it simply comes here that e to the power minus of t and t to the power, this is half into t. So 1 plus half. So this is 3 by 2, t to the power 3 by 2 dt. Now when this is in this form, we can say this is in the form of a gamma function. So now here we have integration 0 to infinite e to the power minus of x and x to the power n minus 1. So what is the power n minus 1? So here n minus 1 is 3 by 2. So what is n? N is 5 by 2. Now you have 2 into gamma of 5 by 2. Gamma of n. Gamma of 5 by 2. It's a standard form. We are just simplifying this one. So what we can write? 5 by 2 can be 2 multiplied with 5 by 2 means this is n minus 1. So this is 3 by 2 into half and gamma of half. You can just multiply all these things. It simply becomes 3 by 2 because we have 2 over there. 2 will cancel out. This is 3 by 2. And gamma of half, we have already shown this thing. This is root of pi. So your expression, if this is in this form, we need to put this thing in a generalized gamma form so that you can have the solution. Now you have the next problem. Now here we have two integrals in a multiplied form. Now one is x to the power, e to the power minus x cube divided by root of x dx, and the second one in the multiplied form e to the power minus x to the power 6 x to the power 4 dx. So how to simplify this thing? Again the form is in a bit complicated one. So we need to simplify this one, generalize this one, so that we can put this thing in a generalized gamma form. We are assuming x to the power 3, this is equal to t. So x is given as t to the power 1 by 3 dx. So this is 1 by 3 t to the power minus 2 by 3 dt. Now x tends to 0, t tends to 0. X tends to infinite, obviously t is also tends to infinite, so limit is unchanged. Now put this thing in this expression. So e to the power minus of t, so I have already considered this is t to the power 3 is equal to t, so it's become in a simplified form, e to the power minus of t, and you have under root of x, so this is half, x to the power half. So half means this simply gives you t to the power 1 by 6 because the power is 3. And you have dx, so dx equal to this factor 1 by 3 t to the power minus of 2/3 dt. Let's put these things in this equation. So our first integral is placed in this form. And the second integral, what is there? We have e to the power minus x to the power 6. X to the power 6 can simply be written as e to the power minus t square. And this is t to the power 4 by 3 and dx is equal to 1/3 t to the power minus 2/3 dt. So this factor is. So after simplification, taking the constants out, so in a very simplified form, it comes in this form that e to the power minus of t t to the power minus of 5 by 6 dt. So this is in a very simplified form. And you have e to the power minus t square t to the power 2/3 dt. So you can just simplify this one. You can just put these things. This is 1 by 9. So this expression becomes gamma 1 by 6. So the first integral is given as gamma 1 by 6, because this is n minus 1. So this factor is n minus 1. So gamma 6. And the second integral, you have e to the power minus t square. So this is half. We can take half over there, and gamma 1 minus 1 by 6. So simplify this one. So you have it expression. And this particular form we have already shown in the last property of the gamma function, that it shows that gamma n, gamma 1 minus n, this is equal to pi sine of n pi. So I have just replaced this one by using this particular relation. Now again we have another expression, e to the power minus x square, x to the power 9 dx. So to simplify this one, what we are going to do, we are going to consider x square equal to t, so that e to the power we have e to the power minus of t. So this will be very generalized form of a gamma function. And obviously x will be t to the power half, and dx can be given as half into t to the power minus of half dx. X tends to 0, t tends to 0. So obviously x tends to infinite, t also tends to infinite. The limit will be unchanged. Put all the values over there, and after simplification it simply gives us half into e to the power minus t to the power 4 dt. So it's in a generalized form of a gamma function. So gamma function, what it shows, that e to the power minus t to the power n minus 1. So n minus 1 is 5 minus 1. So obviously this will be gamma of 5, and you have one half over there, half into gamma of 5. Simplify this one, you will get the result for this integral. Now you have another one in a bit different form. So what is this form? Here we have tan function. You have tan to the power 3 plus tan to the power 5 e to the power minus tan squared theta d theta. So it is nowhere looking like a gamma function generalized form, but still we can put this thing in a gamma function form. So what we have to do, we are going to consider t square equal to x. Now we know t square equal to x means dx, this is equal to tan square theta, this is equal to x. Tan square theta, this is equal to x. So dx, this is equal to 2 tan theta sec square theta d theta. And if you take common 2 tan theta, if you take common, this becomes 1 plus tan square theta d theta. So just we can write this thing. So a simplified form. So tan square, this is equal to x. So this is x. So this is 1 plus x. Inside the bracket, this is 1 plus x. And you have tan of theta. So what is tan theta? So tan theta, tan square theta is equal to x. So tan theta can be given as root of x. So this 2 tan theta 1 plus tan square theta can be simplified in this form. The 2 under root x 1 plus x d theta, this is equal to t of x. So what is d theta? This is 1 by 2 root x 1 plus x dx. Now the important part, what is the limit? Now here limit is 0 to infinite. So when theta tends to 0, so obviously when theta tends to 0, x also tends to 0. And when theta tends to pi, x tends to gamma. Now it is helpful for us. So this becomes integration limit tends to 0 to infinite. And when you put this thing in this expression, what you have excess tan to the power 3. So tan to the power 3. So tan to the power 3 I am writing in this form x root of x. So tan square is equal to x. Tan square, this is equal to x, and tan is equal to root of x. So this simply gives us tan cube. This gives us tan cube. So in that form we are also calculating tan of phi. Tan of phi means when you square this tan square, this becomes x square. X square. So it becomes tan to the power 4. It becomes tan to the power 4. And the another one given as root of x. So it simply becomes x root x and x square root x. Okay. And here we have considered tan square equal to x. So it simply becomes e to the power minus of x. And what is dx? Dx we have already, sorry, d theta. What is d theta? D theta we have already calculated it. This is equal to 1 divided by, or dx divided by 2 of root x 1 plus of x. You have this expression. Now we can just simplify this one. Take common x root x 1 plus x e to the power minus x divided by 2 into root x 1 plus x. Now we can see, you can see root x 1 plus x, root x 1 plus x, this is a common section. So you can simply cancel out. So what is left with? It is simply left with integration within the limit 0 to infinite x e to the power minus of x dx. Now this is x to the power 1. X to the power 1 means 2 minus 1. So this is gamma of 2. So half into gamma of 2. And gamma of 2, this is equal to 1. So we have this expression for this. Thank you. So today we will discuss about gamma function, some of the properties of gamma function, and some of the problems related to the simple problems related to, if you have your expression in another form, we can just try to put this thing in a gamma function form so that our solution will be very, very